Previously, we covered the core foundations. Now in part 3, we tackle Venus, surface, and geology. Venus, surface and geology. Orbital dispatch. Venus series. Episode 3. Venus is the most geologically complex terrestrial world we've visited, and we still don't know whether it's geologically dead or quietly active right now. That single unanswered question shapes everything we think we know about its surface. Last episode, we looked at the Venusian atmosphere, that thick, crushing blanket of carbon dioxide and sulfuric acid clouds that makes the planet so difficult to observe from above. Today, we're going beneath those clouds, down to the surface itself. The core question for this episode: what does Venus actually look like down there, and what has shaped it? Because the answer is stranger and more scientifically significant than it might first appear. For decades, the surface of Venus was completely hidden from us. Optical telescopes are useless against those clouds. The breakthrough came from radar, NASA's Magellan spacecraft, which arrived at Venus in August of 1990, spent 4 years mapping roughly 98% of the surface using synthetic aperture radar. What it revealed was a world dominated by vast volcanic plains. Roughly 80% of the surface is covered in relatively flat, basaltic lowland, formed by ancient lava flows spreading across enormous areas. This isn't the kind of rugged, crater-scarred terrain you'd expect. Venus is surprisingly smooth overall, and that smoothness is itself a clue worth holding on to. We'll come back to it. Scattered across those plains are two types of highland. The first are shield-like volcanic regions, massive upwellings of material, the largest being Aphrodite Terra, roughly the size of South America, sitting near the equator. The second are the continent-like highlands of Ishtar Terra in the north, home to Maxwell Montes, the highest point on Venus, rising about 11 kilometers above the mean surface elevation. But perhaps the most unusual features are structures found nowhere else in the solar system. Coronae, crown-like circular formations, some hundreds of kilometers across, are thought to form when plumes of hot material from the mantle push up through the crust, cause it to dome, then collapse back. There are hundreds of them across the surface. Alongside those are Tesserae, highly deformed, ancient terrain that appears to predate the surrounding volcanic plains. Those Tesserae are important. They may represent the oldest surviving geology on Venus, and some researchers think they could tell us about a time when the planet was radically different. We'll see why that matters in a moment. Here's where we return to that smoothness. Venus has relatively few impact craters, roughly 1,000 spread across the entire surface. That's strikingly low. Earth is active enough to erase craters over time. So why does Venus have so few? The leading hypothesis is a global resurfacing event, a period perhaps between 500 million and 800 million years ago, where enormous volcanic activity essentially repaved most of the planet, burying or obliterating older craters in the process. If that happened, it would mean the surface we see today is geologically young. But here's the open question. Did that represent a one-off, catastrophic event, or is Venus still active in some form? Recent data from ESA's Venus Express mission and a reanalysis of Magellan's radar data have suggested that some volcanic features may have changed on timescales of months to years, consistent with ongoing activity. This is not confirmed, but it's credible. The upcoming Da Vinci and Envision missions in the next decade should help settle the matter. Venus has a surface that tells a story, but it's a story with pages missing. A young volcanic plain, ancient deformed highlands, and structures that have no parallel anywhere else we've explored. It's a world that has clearly been through enormous geological upheaval and may not be finished yet. Next time, we go deeper, literally. We'll look at Venus's interior structure and its unusual rotation, which raises its own set of questions. If you want to follow the full series, The Venus playlist is linked in the description. And if this kind of careful, no-nonsense space science is what you're after, subscribing is the straightforward way to keep up. That is part 3 of Venus. In part 4, we explore the next key question. Subscribe so you do not miss it.